Alright, so in the previous page we have introduced how to partition a relation into buckets, and we also show the requirements or the constraint for the size of the relation versus its memory size, right? And in this page we want to show you how to use this hash-based algorithm for implementing this duplicate elimination operator, which is delta R, right? We have shown this operator many times before already. I hope you still remember this notation, right? So we have used how to implement this operator with both one parse as well as two parse algorithm. In this page we will show you with another two parse algorithm based on the hash function we showed before, right? So for this two parse algorithm we also have two steps. For the step 1, which will be similar to the previous page we show you, right? So given a relation R, we can partition this relation R into buckets. So in step 1, we have to design this hash function very carefully. Here we are starting this duplicate elimination problem, right? Or this operator. So we can define this hash function we showed in the previous page according to all the attributes of the relation. So given a tuple in a block, depending on all the attribute values of the tuple, we can map it to a bucket. In other words, for the tuples with the same value, they will be partitioned and they will be assigned to the same bucket, right? So this is step 1. We can design this hash function according to our requirements. Based on this bucket, we can further do one step, step 2, and we can apply this duplicate elimination to each of the bucket. Given the partition results, we can load each bucket into the memory, right? And we can apply the one parse algorithm to dealing with this bucket, which will be, the one parse algorithm we showed before already, right? So we can apply this duplication elimination on each bucket, so we can ensure for the tuple with the same value, we will have one single copy in the result. So, based on this description, for the step 1, we have to read and write, right? So therefore, the cost for the step 1 will be about 2 BR, and for step 2 we have to read the buckets into the memory. The cost will be about 1 BR. So therefore the total cost for this operation with the two parse algorithm according to the hash functions will be 3 BR instead, which will be the same as we showed before, right, with the two parse algorithms. And we also have one assumption here: the BR is not greater than the M squared, which is based on what we described in the previous page, so we can ensure we can load each bucket into the memory. Alright, so this is how to design duplicate elimination operator with a hash-based algorithm. Alright, so besides this duplicate elimination operator, another operator we will show here is the gamma R. I hope I still remember this gamma R. It denotes a grouping operator. And before we show this gamma is on city, and we want to calculate some price for all the houses in the city, right, for the relation R. Here we just ignore this city as well as the housing price summation, this notation or the subscript here. We have shown you how to implement this operator with both one parse and two parse algorithm before already. And here we want to show you with another algorithm with the two parse algorithm based on hash functions instead. So for this algorithm, we also have two steps, right? And the first step 1 is to partition this relation into buckets. However, here, we are doing a grouping as well as aggregation, right? So therefore, we have to design the hash function in the partition process carefully according to our grouping attributes. In other words, for the tuples with the same city, for example, we will assign them to the same bucket. And in this way, we can partition the relation R into buckets. For each bucket, all the tuples inside them will have the same city. And another step we have here is to apply a grouping operator to each of the buckets. And we have to read each bucket into the memory and then apply a grouping operator on them. So we can see, we can know the average price or the sum price for all the causes inside the same city in the relation R. So which is actually very similar to the duplicate elimination operator we showed in the previous page. So the cost for this operator, based on the algorithm, will also be about 3 BR, because for step 1 we have 2 BR cost, and for step 2 we have to do the reading right into the memory. It will be 1 BR. The total cost will be 3 BR, and we have assumption that BR is no greater than M squared, which will be very similar to the previous page. We can ensure each bucket can be loaded into the memory if this constraint can hold. Okay, so this is a grouping operator based on the hash-based function and algorithms. Next, we will show you how to do the join based on two parse algorithm according to the hash functions instead.